Welcome to the first science session, totally science session. We all are scientists here and we have a habit of standing and delivering. So we will stand here at the podium and deliver our talks, and then we will have question and answers at the end of all the talks. Well, this picture fascinates me. This shows the global population density. As you can see, most of the population is concentrated in Asian region, especially the region dominated by monsoons, which is South Asia and East Asia. But the highest impact of climate change is felt in the polar regions, especially in the Arctic, which has resulted in unprecedented ice melting and warming. But as you can see, the human population is in these tropics and subtropics and mid-latitudes. So this session explores how the climate change happening in the Arctic influences Asian climate and monsoons and thus lives of billions of people. Now, since morning, we have been listening how Arctic is related to Indian monsoons and Asian climate. So this session puts forward hard facts and pieces of evidence, stressing the connection between the faraway Arctic and the Asian climate. I am Manish Tiwari, a scientist at the National Center for Polar and Ocean Research under the Ministry of Earth Sciences. My institute, as we like to call it, is the Indian gateway to the polar regions. We take care of all the polar scientific and logistical activities of India, and I lead the Arctic Operations Group, which manages our annual expedition to the Arctic. Research-wise, I study past climate over last hundreds to thousands to millions of years, and I will show you how Arctic is connected to Indian climate over millions of years. The structure of the session will be as follows. I will give an introductory view about the topic, specifically focusing on Indian monsoon and especially the past research. And then we have three illustrious scientists here who will give around 10 minutes talk, and then we will have question and answer sessions at the end of all the talks. Before proceeding with my talk, I would just like to give a brief introduction about the researchers sitting here. First, we have Dr. Hiroyuki Enomoto from National Institute of Polar Research, Japan. He is a PhD in cryospheric science, sea ice and climate, and he is presently the project professor at Arctic Environmental Research Center and Vice Director General of the National Institute of Polar Research. Then we have from Korea, South Korea, Dr. Seong-joong Kim. He has a PhD degree from Texas A&M University and is presently Vice President of Korea Polar Research Institute and a professor at Korea National University of Science and Technology. He is a bipolar man. He has been to Antarctica and has been the not bipolar disorder, but bipolar scientist. So he has been a leader of the overwintering team at Antarctica, and he's a prolific author, more than 140 papers, including papers in Nature, Science, and Nature Communications. And then I have with me my colleague, Dr. Avinash Kumar. He has over 20 years of polar research experience, contributing to several publications and earning various awards. He is currently a senior scientist at NCPR, and his research explores polar climate linkages and sea ice variability using remote sensing. With this, I would give just a brief overview of the topic. Okay, so here you can see that how global warming is taking place, and the temperature have now crossed 1.2 degrees Celsius, and on this side below is the what you call is above is the carbon dioxide level, and below you have global temperature change. So you can see that the temperature is following the CO2 very beautifully, very faithfully. It shows that, and over the last few years, we see that how exponential rise in CO2 has led to exponential rise in temperatures. Now there are several climate tipping points. Now these tipping points are the points, if Earth crosses those points, then they are point of no return. It means that Earth will go into a fundamentally different climate scenario. And most of these tipping points are located in polar region, especially in Arctic region. Arctic sea ice is one of the very major important tipping points. That is why we all should be worried about Arctic sea ice. Now, Arctic is changing and its temperature is increasing 4 times the global warming. Now, that is because of what is known as Arctic amplification. It has mostly to do with albedo effect, which is when the sea ice melts, the water is exposed, and more of the heat is absorbed, which gives a positive feedback. Because of that, Arctic's average temperature is increasing up to 4 times the global average. But as you can see in the picture next to it, there are some regions where the temperature change is almost 7 times the global average. So there also it is spatially varying. And in response to this temperature change, the Arctic sea ice has been decreasing continuously. And you can see here decadal variability in sea ice, and now the present decade has the least sea ice. Now coming to Asian monsoon, it is the lifeline of billions. So the question is how Indian monsoon is going to behave in a warming scenario and how Arctic sea ice is going to affect it. So the models have shown that in a warming scenario, all the models show that the monsoon precipitation is going to increase. But that increase will be spatially variable and extremes may increase. Now the question before us is whether Arctic sea ice is affecting the Asian climate and Asian monsoon, and if so, how? This can happen through what we call as atmospheric bridges and oceanic tunnels. As you can see in the picture on the right-hand side, we have oceanic circulation, which shows that how we talk of two poles, Arctic, Antarctic, Indian Ocean, but if you see, all the parts of Earth are interconnected. These oceanic circulations are like blood veins in our body. We have blood veins carrying signals throughout our body. Like that, there is an oceanic and atmospheric circulation which carries signal from one part of the Earth to other part. So that is how these regions are connected. That is how Asia is connected to Arctic. There have been several studies from our institute recently which shows that how Arctic and monsoon are connected. I will show only a couple of slides, too many to cover here. This is one of the earliest one where by our institute, Saurav Chatterjee and Dr. Ravi Chandran, who is also sitting here, Secretary of Ministry of Earth Sciences. And here we see that whenever sea ice extend, the Arctic sea ice extend is spatially negatively correlated with the frequency of extreme ISMR events. That is, whenever there is less sea ice, there will be more extreme events. So in the present scenario of global warming, the extreme events over India, that is droughts and floods, are going to increase. That is observational data. There are model data also, which are this is one of the study which is under review currently, which shows that with decreasing sea ice, the monsoon rainfall is increasing, and it is increasing in those regions where not much rainfall happens, which is in arid areas of Gujarat and Rajasthan and Himachal Pradesh and Himalayas. So these increased rainfall is going to cause their floods and landslides, etc. And again, these are the examples of extreme events. And then we have paleoclimatic data from our own research, where we have studied sediment cores from Arctic spanning the last thousands of years. And there also we have found that whenever there was warmer Arctic intervals, there was higher ISM precipitation. But we never have CO2 in the past, which we have now. Right now, the CO2 concentration is almost 421 ppm. This is ice core data, which goes for the past 800,000 years. So even during the past 800,000 years, we never touched what CO2 we have now. So if we want to check what will happen, we have to go further back in time. Once we go further back in time to a period which is known as mid-Pliocene warm period, the red arrow shows that location in geological time scale. So this period was almost 3 million years ago when CO2 levels were as high as today. So when we studied that region, under a large international program, collaborating with Norwegian scientists and UK scientists. And when we see that data, we found that the precipitation during that time increased. As you can see in that map, the red color shows higher precipitation, more precipitation. Blue color shows less precipitation. And it was correlated with sea ice. Lower Arctic sea ice led to stronger Indian summer monsoon 3 million years ago. So this connection between Arctic and sea ice is millions of years long. And here again, you can see this precipitation, this precipitation increases, you can see in the right-hand picture, this precipitation increases again spatially variable. The precipitation is going to reduce in Indo-Gangetic belt and northeastern areas and eastern India, whereas it is going to increase in the southwestern and over Mumbai and Goa and Konkan coast. It is going to increase over arid Gujarat. It is going to increase over Himachal Pradesh and Himalayan region, where it will again destabilize the climate and landmass. And when we compare it with modern data, on the left-hand side, you have the modern data. There you can see that last 100-year data. There you can see it matches very well with the past data. So the CO2, increasing warmth, increasing CO2 is going to increase the monsoon, which is related to Arctic sea ice concentration. So finally, the takeaway is that Arctic impacts Indian monsoon significantly. Our observation, model, and proxy data has shown that. Now, right now, tropics control most of the interannual variance in the Indian monsoon intensity. We are worried about ENSO, El Nino, Southern Ocean, La Nina, etc. But as you can see in this graph, the temperature over the poles are increasing much more than the other parts of the world. So as this temperature is increasing, this will have an effect over Indian monsoon as well. A warmer Arctic and lower sea ice extent will lead to stronger monsoon, but it will be spatially variable and will have increased likelihood for extreme events. So with this brief introduction, I would start with our speakers. And the first speaker I would like to call is Dr. Hiroyuki Enomoto. Please. Thank you very much.
So my name is Hiroyuki Enomoto from the National Institute of Polar Research, Tokyo, Japan. So I want to talk, this is a good opportunity to talk here and share the scientific knowledge to the more public audience. And my title is the need of to understand, predict, and respond to the with the impact from Arctic Asia. So Japan is implementing many big Arctic program since last 2011. Many big investment was done, and this is one reason why Japan is so intensively doing Arctic science. And this, I worked with the IPCC cryosphere and ocean report, and also continuing the contribution to the IPCC. This is a recent one. The left-hand side is temperature. So there is a many honeycomb type grid, and many part is so-called Asia, Central Asia, and East Asia, Southeast Asia, and so such a Asian country is indicated by the circle orbit and orbital. Then this is a temperature increase, and also precipitation increase is the right upper side. Also, Asia has a big evidence of the increase of the precipitation, and the drought is a regional evidence. And so Asia is under the big influence of this global warming. And this is I copied from the Japanese scientific journal. It's last year in New Delhi, 49.9 degrees Celsius is a recorded high temperature here. And also in many countries, or many, even in Japan, high temperature was recorded in the last 4 or 5 years. Japan has never high temperature than 40 degrees before, 1 decade before, but recently you have 41 degrees Celsius. And so such a extreme hot condition is happening in the world. And the impact is not only summer, but in winter time we have very special impact from the Arctic. And left hand side shows in the Arctic ocean is reducing sea ice, and the Arctic is warming, but at the same time, Eurasian continent is cooling. So-called warm Arctic and cold Eurasia type is happening. And from Arctic Ocean, the cold wind came over Eurasia and arrived to the Japan. And sorry. And then not only the warm Arctic, the Japan is experiencing very cold winter and also heavy snow condition 3-4 times more than usual standards. is experienced in Japan. And this is one forecast from or explanation from the Japanese Meteorological Agency. Japan had a very heavy snow and cold condition in winter time, and the forecaster and also meteorological office analyzed, also scientists tried to find the origin of that extreme condition and going to arrive at reach at the Arctic Ocean. Over the decreased sea ice condition, so atmosphere in the over the Arctic Ocean changed the wind direction or atmospheric circulation pattern, and that's finally come to Japan. And then also westerly wind over India or Himalayan region is also connecting with these conditions. And then researchers is writing scientific paper and published in the scientific journal. But the government or meteorological agency asked the useful knowledge or useful for the prediction is so requested. And then we worked for the knowledge for the meteorological agency useful for the predicting extreme conditions. And that is now operating in the Japanese meteorological agencies. And in summertime, as I told, Japan had a very hot summer recently, and we are not looking around surrounding area of Japan, and also we are looking at the subtropical high pressure in Pacific Ocean. That is a very traditional way to find the reason. But recently we are looking the westerly wind coming from the over Himalaya or over India, and that is also shifting. That is we are looking for finding the reason of the Japanese hot summer condition from the Indian monsoon region impact to Japan. And this is also a copy of the IPCC report. Or in the future is a future projection, 1.5, 2, and 4 degrees Celsius in the future is projected. And also left underside is precipitation is expected, so predicted to increase in many places, even so especially in the Asia, we see the very green point. And soil moisture has also related to the heavy rainfall, and but the soil moisture has a very big regional difference. Drought area and flooding area is related to that. And connecting that extreme weather or climate change, World Economic Forum is publishing every year a risk report. And the left-hand side is a short-term concern to the future. And the right-hand side is the long-term, 10 years. And green color is environment-related risks. And in a long term, the first 4 risk is climate change or extreme weather. That is a concern from the Economic Forum. And finally, I just summarize so many things happening in the Arctic and relating to the Eurasia and Eurasia to Asia, and also we are trying to predict the extreme weather which is happening very often in recent years. So thank you very much.
Hello everyone, I'm Seong-joong. Can you put my figure? Okay, previous speakers all talk about the global warming. It's about 1.9 degree, but 1.09 since about 1850. But this is a much larger amplitude compared to the previous natural variability since about 81 years. So now ongoing warming is quite unusual, right? It's quite obvious. And even more obvious, more seriously about the Arctic, 4 times larger than the global mean, especially in winter time. Summertime, we don't have much global warming in the Arctic. Then why the Arctic is warmer than the rest area? There are many very complicated reasons, but I cannot go over these details. But when you look at the Arctic, temperature trend is very, if you look at the red color, it's like a very rapid warming. But if you look at the middle latitude, Eurasia, there is a cold, the color is blue, right? That means a cooling trend. So this cooling trend is in our daily life, it looks like this. Cold outbreak. For example, in 2025, January 10, Seoul was about minus 18 degrees in Celsius. That was very unusually very cold. At that time, the weather chart looks like this Siberian high and East Asian trough. In between, the East Siberian cold weather is directly blew to the Korean Peninsula all the way to Taiwan and some Philippine or South Asian countries. When you look at the Arctic that time, the Arctic is very warm. So this figure, the red color means the Arctic is warmer than normal. So in the bottom panel shows the so-called Arctic Oscillation Index. When Arctic is warmer than normal, Arctic oscillation is negative. So if you look at the right end of the figure, Arctic is very warm and the index is very low. That means somehow the previous figure is connected to the Arctic. That's my claim. Then how? This is our claim. There is a polar vortex. The blue color is a stratosphere, about above 10 kilometers and above. The red color is a troposphere polar vortex, below 10 kilometers. So if you look at actually the two blobs, the polar vortex circling around the globe. And there are two pathways. From one is through lower troposphere, another one is through stratosphere. So I'll illustrate a little bit the scientific issue, but when you look at the Arctic sea ice, when the Arctic sea ice is less than normal, you have a cold air outbreak in East Asian countries. This is the figure what that shows. So it's a bit complicated. When you have a lower sea ice in the Arctic, you have a very cold air outbreak from the all the way to the Arctic to East Asia. This is what the figure says, but it's a little bit complicated. This is the pathway through stratosphere. So when you have a lower sea ice in November and early December, in the Arctic area, the blue color is lower than a normal area. You have a high pressure over the Arctic, and also the blue color that is in Eurasian area, in the observation and the simulated. So if you figure out the relation between Arctic sea ice and the East Asia cold air outbreak, you can predict seasonally. That means about 3 months ahead, you can predict. So when you have a lower sea ice in the Arctic, you can predict after 3 months, there will be a cold air outbreak in East Asia, all the way through like Philippine or South Asian countries. So this is very critical to understand what to apply in the actual prediction. So this figure shows the red color means Arctic is getting warmer and warmer and pressure is getting higher and higher. So probably due to the reduction of sea ice and also increase of Eurasian snow cover. This figure is a little bit complicated, but this is the so-called polar vortex behavior in the stratosphere level. We can classify into 3 types. When you have, depending on this type, you have lower than normal or warmer than normal in the Eurasian areas and also North American countries. So finally, the East Asian winter cold air outbreak is in part linked with the Arctic warming, not entirely, but in part, that means that resulting in higher pressure over the Arctic, that weakening the polar vortex and cold air outbreak happening in East Asia. This is due to delayed sea ice curve in the Arctic through troposphere and upper level stratosphere. And the Arctic pressure is getting increasing right now. So this means weakening of a polar vortex will be somehow ongoing in the near future. That means probably more extreme weather, especially in wintertime, will occur in the East Asian countries due to the Arctic warming. Thank you.
Thank you, Dr. Seong. And I request Dr. Avinash to give his presentation.
It's my pleasure to listen the previous speakers. They talk about that how the Arctic connecting with the Asian region. And as per the concern, my talk, I will be going to talk about that understanding the Arctic with the Indian monsoon, their connections. So as we know that Arctic is very far and compared to the India, and we have a very complex processes to understand how the monsoon is affecting to the Indian monsoon and from the Arctic. So we will be, since the morning we are listening that the global temperature is getting to be increased with the time. So when we look for the longer record, for the 150 years of the record for the global temperature, we can see that the temperature is drastically getting to be increased. And over the last, what we say that the past 10 years, though it has recorded the warmest period in the history. And this record which we have observed that it says that every decade it's having a 0.2 degree centigrade increase is there has been recorded. And in the 2024, it was the first time the annual average has been exceeded for 1.5, 1.6 degree centigrade in the year of 2026. So what happening exactly when we talk about that temperature is getting to be increased? So directly it is getting impact on the sea ice. So as we know that Arctic sea ice is drastically reducing since the satellite era which we have 1979. We have seen that our study, we have found that even in all the seasons, even summer, winter, and the other seasons, we have a drastic decline in the Arctic sea ice. So this is the study which we have shown. It is up to the 2018, where we have into 19, we have recorded in September. It is the lowest record which we recorded. And we can see there is a drastically, you see the sea ice as a reducing as well as the volume. Volume have a drastically reduction in the volume. So the resultant, what is happening, we are losing the multi-year ice in Arctic, especially in Arctic region. And that reduction in multi-year ice, it's getting ocean warmer and warmer. And this warming it's again leading for the delaying in the winter sea ice formations. So when we look for another record, it's a recent record about the global sea ice, we can see it is a 2023 was, in the February 2023 was below the record was recorded till the history. But right now in the 2025, we have recorded it the lowest in the global sea ice record. As well as you see the Arctic and Antarctica. We can see the Arctic is, overall in Arctic, we can see the minus 4.5% per decade is reduction is there. However, it is in Antarctica, it's marginally less, but also it's because we have bigger land, so also it is having a 0.5. And as per the global also, we can see the 2.5% per decades. So what is happening? If we are seeing the one part, we have seen the Arctic sea ice is declining. But when we concern about the Indian monsoon, so Indian monsoon rainfall, which has been taken from 1980-71 to 2023 records, it has been done by IITM, IIMD, by the Indian agencies. They have computed this data. We can see that they have taken the threshold for the if plus 10 and minus 10, below 10 it is given as a dry period, and where it is getting as a wet period. So we can see there is whenever the processes you are seeing that El Nino, wherever that's forming, it's very well aligned with the drought seasons. Wherever we are saying that The La Nina has formation is there. The blue dots with the bars, you can see there is a maximum, it's aligned with that. And there is a, if you see the longer range, how the trends is happening, till the 2020, we were having in the drought periods. But in India right now, from the 2020 onwards, we are getting in the wet periods. So this is the record which we have seen here. So its questions come that if it is seeing the longer period, so last 40 years, if you see the record from the CREP record, so they say that in the 40 years, 23% of districts experience the both deficient and the many have the excess rainfall has been recorded in the India. Whereas the significant, it traditionally has been changed. Earlier we were thinking that Rajasthan and other regions like Gujarat and Maharashtra, Tamil Nadu, there was a low rainfall, but the recent period we have seen the significant increase in their rainfall. Whereas the other is the reduction which has been recorded from the June to September in the rainfall on the tehsils of the Indo-Gangetic plains, northeast of India and Indian Himalayan regions. And this reduction is there, but as subsequently the 64% tehsils we have recorded that there is extreme frequency has been increased in the past few decades. And the this is going to be major impact going to be happen on in the Indian our economy. So Indian, as we know that India has a backbone the agriculture, and there is they have without the agriculture we have a water security. So agriculture we are around 70 to 90% we are dependent on the annual rainfall. So about the 55% farmland of the fed up with the monsoon, and it's critical for the food and the rural livelihoods. Also that when the rainfall is happening, the river get replenished, the groundwater which is getting to be recharged, as well as this is the boost the economy, stabilize the food prices and the other sectors. And as well as also with the recent events which we are getting drastically changes, it's also creating lot of the floods and drought events in the recent period. So when we have seen the present scenario, so it has come what are the theories behind the Indian monsoon? So because it's very volatile, because we are having a very long Indian oceans, and as well as it's a far process from the Arctic. So it is what we say, we have a bigger land, it's a heating of Indian landmass. This is one of the major cause happening. Also the intratropical convergence zone, which is also, it is a equator to trade winds is coming. That wind is also bringing the lot of moistures, and also it is getting to be Indian monsoon, it is getting to be. Also another factor is the Somalian jet streams. That also is the similar processes from the ocean to the land mass, it is getting to be moist air, and the monsoon is getting to be trapped in here. Subtropical westerlies wind, mascarene high pressure system, and as well the ocean atmospheric interactions like INSO and IOD. These are the major component which has been taken in a prediction system for the Indian monsoon. So as we have from this morning with this gathering, we wanted to know that what is the relevance for the Arctic research in India. So first of all, we wanted to know about that how the Indian monsoon and their rainfalls pattern. So that is going to be linked with our economy. That is the temperature patterns. We are having a lot of extreme temperature events are happening in recent periods. We have extreme weather condition is happening in India also. So we have also the Arctic research and resource explorations. We have a climate change adaptation and policy implications for the India. Also, we are looking for the international cooperation and Arctic governance on that. So based on that, we are coming about the scientific component, that how the impact of Arctic oscillation on the Indian monsoon. So there is a study has been done by Midun and Dimri. They have done about the Arctic oscillation influences on the winter monsoon. So they found that during the positive AO years, the low pressures and the colder conditions which prevail in the polar regions, along with the stronger westerlies in the Antarctic Sea. So these are the reasons which has allowed the polar extratropical mass move toward the southward and mid-latitude interactions that enhancing the precipitation in the northern part of India. So they have recorded that whenever the positive Arctic oscillation is happening, the northern part of India, we are getting the good rainfall in that period. Wherever the negative periods we are getting, the rainfall is also getting to be reduced. Similarly, there is a study by Yadav et al. From the ITM. They have done about that whenever the positive AO is happening. That is strengthening the westerly jet streams, and that also leads for the western disturbance, that increasing the precipitation of northwest of India. So another study which we are going to talk about, the Prabhu et al., they found out about that how the summer monsoon variability over the northeast India, and it's associated with the Eurasian snow, Atlantic sea surface temperature, and Arctic oscillation. So as we know that during the Eurasian snow variability affect the summer monsoon over the northeast of India, especially during the January, when the snowfall increases more, that also it leads to, during that excessive snow.
Avinash, 2 minutes.
Yeah, it leads to the reductions on the Arctic oscillations, and that's what the process is happening, and as shown in the figure. So as of my colleague, Dr. Manish Tiwari already has shown about the Chatterjee studies, they have found out that whenever the Arctic sea ice, if you see the longer term of record in the graphs, when it is the long term, when we are saying the Arctic sea ice is declining, and whenever it is declining, our monsoon system is also overall declining. But they have found in the monsoon system, but the extremity has been increased. So you can see the red and the blue lines, it is say that whenever such condition is happening, extreme events is increasing in the Indian prospects. So the mechanism, they says that there is a jet stream characteristic and anomalous meridional circulation that leads for the circulation and enhance the moisture to the convergence. So I'll not go in details. I'll just say one of our important study. So recently we have done with the COPRI, there is a collaboration with the COPRI and NCPOR. We have done one study. We have taken the spring, especially the spring of the month, so season, to know about how this spring is getting to be affected to the Indian monsoon. So we have to use the very advanced techniques of SVD. It's apart from the PC and that EOF analysis. So we have advanced techniques where we have taken the two variables. One is the sea ice, one is the monsoon. And we have taken together. So if you can see, there is a graph. One shows that one figure and spatial plot for the India and as for the Arctic concern. So it is well correlated, and it says that around 75% of the correlation we have received, that wherever you can see the blue, it's not about the percentage or not about the correlation. It says about that blue colors, wherever in India and Arctic, it's linked with their changes. If any changes happening, we are recording in such processes very frequently. Further, we have done about that, we have taken so this was the study we have done. So in this, if you see that complete condition, when we have taken the regionally, we have taken the two region, not over when we had analyzed with the Arctic alone, the relations was not up to mark. So we have thought about that. We have to see the processes, where is the regional basis working. So we have taken one part is the central Arctic region, and one is for the Kara variant region. So it is very clearly, we can see when you take the total, if you see the right graph B, it says that is a negative correlations. It's negatively related with that. But when you say the central Arctic region, so it is say that's positively. It's with the monsoon and the sea ice, it's a positive, whereas the Kara variant shows a negative effect. So this was the study we have done. And finally, we got it that how the central Arctic high sea ice they have a strong pressure gradient between the high and mid-latitude regions that strengthen the Asian jet, and the northward for the region induce the anomalous high pressure over the central India region, and that leading for the easterly southwest region and increasing in the monsoon particularly in the central Indian Ocean, central Arctic region. So similarly so I'll take the final takeaway message for that. What we have seen that over the 40 years, 23% of the Indian district face both the drought and the flood conditions, and 50% tehsils, which is having increased the rainfall. And when you talk about the Arctic influence on the monsoon, declining sea ice, particularly in the central and the Caribbean region, that's significantly affecting the atmosphere circulation and the wind. The regional rainfall shift, like Rajasthan and Gujarat, seen as a increasing rainfall, where the Indo-Gangetic plains, northwest India, reduce the lower rainfalls. And the critical role of the Arctic sea ice is it's like monsoon leakages, which is improving our monsoon prediction system and managing the agriculture, planning, and resources, and mitigation for the higher risk and disasters needed. Also, we need a collaboration to enhance our observation, climate modeling, and the international cooperation and essential address to the challenges for the Arctic-driven changes and monsoon and climate system. So before that, I'll say thank you to everyone.
Thank you. Thank you, Avinash. I in the beginning said that we are going to present some hard data, and I hope these were not too hard on you and did not make you sleep, because they were a little bit complex and complicated. So if there are any questions from the audience, yes, please, from the front, in the front.
So my question is to you, Dr. Manish Tiwari, sir. Sir, you had mentioned a slide and you had highlighted the change in temperature with respect to the latitude. And sir, in that slide, I have noticed that the change in Arctic, temperature of Arctic is much faster than Antarctica. Sir, but Arctic is majorly sea and Antarctica is a bigger landmass.
Yes.
Sir, then why is this change
Yes.
happening?
It's a very good observation. And the reason behind that is that Antarctica is enclosed by a circulation, oceanic circulation, which is known as Antarctic circumpolar current. Now that current is very strong, and that isolates Antarctica from rest of the globe. So the changes occurring in rest of the globe takes time to reach Antarctica because of that Antarctic circumpolar current. Whereas Arctic does not have any such current. It is surrounded by land masses, and all the effect happening in tropics and subtropics, whatever temperature increase is happening, that get transferred to Arctic much faster than Antarctica. That is why Arctic temperature fluctuations are much more than Antarctic temperature. So if any other question, else I have a list of questions for my speakers. We will not spare them so easily. There is one. Yes, please.
Yeah, my name is Jan Gunnar Winter from the University in Tromsø, the Arctic University of Norway. Thank you for very good presentations about the teleconnections. And I will focus on the declining sea ice and the effect on the monsoon. Have you any model projections for future if the relative effect on the monsoon will in a way fade out, because the future Arctic will probably look like it's more or less free of sea ice in summer. So while we now have a very sharp decline, later in the century we will have a more stable seasonal variation. It will freeze back in winter, it will be open more or less in summer. Will that, or have you any data underpinning that the relative effect of what we are seeing today will be less in the future?
Will you take like to take?
Maybe I could answer. At the moment, sea ice is declining very fast. So air and ocean difference is very large. That gives some kind of shock in the atmosphere. I think that seems to influence this interruption of this polar vortex disruption. But in the future, when the sea ice declining is fade away, and there is probably not much difference between atmosphere and ocean, in that case, probably a little bit extreme motive might be mitigated. But the question is, when this thing will happen is a little bit difficult to predict. Because now the sea ice declining is mainly occurring in the summer season. Summer season decline influenced fall and winter extreme weather mainly. But in the future, within like 2050 or so, summer season, the sea ice will be gone. That's what most people predicted. But still in winter, there will be sea ice in the Arctic. That means still there is some contrasting between atmosphere and ocean will ongoing for the time being. So it's a little bit complicated issue, but to my personal feeling, will be mitigated than right now in the long-term future, I guess.
Okay, so there is one more question at the end.
I'm Suprita Suman, working on Arctic politics and on class also. So my question is to Dr. Avinash Kumar. You have mentioned that Arctic melt is somehow responsible for changing or altering the monsoonal pattern in India. So whatever you have given, so is it because during my research also we were studying all these things. So I just wanted to know is this has been proven or it is hypothesis only that Arctic melt will lead to the changing the monsoonal pattern in India. Similarly, warming of third pole, maybe it has some consequences on the Arctic also. So Arctic is the center. Even Arctic climate is changing. Then what is the reason for Arctic change? So it's one-sided. I think sometimes I feel that is whether I'm not sure, but I wanted some more information about this. That whether Arctic is responsible for changing the climate pattern in India, or Indian warming of third pole due to increasing human settlement is responsible for adding some vulnerability for the Arctic region. So
I think your answer you have given in your question itself, that the human is responsible. So you can see that Arctic, since the record, we are talking not about the only just for 40 years or 50 years time, when we have seen the longer records, we could observe that compared to the Antarctica, Arctic is declining gradually to gradually. And then what is happening in the recent periods, the recent period, if you look about that record, and it's not about just we are telling as a hypothesis that if anything Arctic melt is happening and we are India, we are getting some changes in the monsoon pattern. So as per our research and recent we have shown by our couple of research, so they have very clearly observed that whenever the Arctic sea ice is declining a much rate, so we have extreme events is increasing in India. So that is the proven fact. It's not just we are talking right now in hypothesis. Earlier even we don't had our prediction system in IMD and all, but recently I heard the press briefing by our secretary and the IMD. So they have observed that Eurasian snow and Arctic, which could be taken as a major component to enhance our prediction system. So definitely it's working in a both ways.
So now we are really out of time, and only 30 seconds are there as per the.
One additional.
Oh, you want to make a statement? Sure.
The last question, why Arctic is warming is related to the Atlantic ocean circulation is impacting, and that is coming from the Mexican Gulf Stream, and so many things is connecting over the Atlantic Ocean, Arctic Ocean, and Eurasian continent, and came to a monsoon condition. That is a recent understanding from science. Okay.
Well, then we come to the end of our session and have a brief question and answer session as well you could have. And so finally the bottom line is that Arctic may be far away, but all parts of Earth are connected, interconnected, as I told in the introduction. Like we have blood veins in our body, like that there are atmospheric and oceanic circulation in Earth, which are connecting all the parts of Earth. We cannot study them in silos. That is why we need to study Arctic, and that is how Arctic and Asia are connected. Thank you for listening to us. Thank you very much.